Hi everyone, my name is Yale. I'm a 61A mentor, and I'll be going over the second problem for the week 9 worksheet, which is ping pong tracker. And also, I do sound a little weird because I'm recovering from a cold, so please bear with me. We're thriving out here. So the question says, let's use object-oriented programming to help us implement our good friend, the ping pong sequence. And as a reminder, the ping pong sequence counts up starting from 1 and is always either counting up or counting down. And at element K, the direction switches. Let me get my pointer out, sorry. The direction switches if K is a multiple of 7 or contains the digit 7. And the first 30 elements are given here. And you can see that the areas where there are brackets are the areas where you're going from one direction to another. So here we're going in the positive direction, and here we're going in the negative direction, and we're switching because we hit the number 7, which is a multiple of 7 and also contains the number 7. So that's why we want to flip-flop our direction. Similarly here, when we get to 14, which is a multiple of 7, we're going to flip-flop to the positive direction. And this process repeats for the remainder of the sequence. And now you can also assume that you have a function called has7 defined, and that takes in an integer k and returns a Boolean value that tells you whether or not k contains the digit 7. So it just makes your code perhaps, it makes it more convenient for you in your code, perhaps when you want to check up here. So now we also do want to create a class for this particular problem. So we can see here in the doc tests that we're creating two instance variables of the ping pong tracker class. So we have tracker1 and tracker2. And now if you call next on tracker1, we're using dot notation here because that's the way we can call methods on instances of a class. So we're calling the next method on tracker1, and this is going to output 1, basically the first element of the particular ping pong sequence. I was going to say King Kong, ping pong sequence that we're on. And tracker1, if you call tracker next on tracker1 again, it's going to return 2 because that's the next element in the sequence. Now, each of these instance variables are instances of the class, are going to work independently of each other. So if you call next on tracker2, it's going to start at 1 as well. It's not going to continue off and return 3, for instance. So go ahead and try the problem on your own first, and we'll come back to it in a second. So hopefully now you've tried the question on your own first, but if you still haven't understood the question, maybe this template will help you out. So if you want to pause it now again and try the question, go for it. But otherwise, I'm going to start going over how to approach this problem. So there's a couple of things you want to think about when approaching this problem. First, the first thing you might want to consider is how do we keep track of everything that we need to know, right? So as you can see in the particular sequence, you want to be able to check the element the sequence is currently on in order to tell whether or not it's a multiple of 7 or contains a digit 7. So the first thing we want to keep track of then would be a index. So we're going to create a new index for every single instance of the class, as you can see up here, because all of them work independently of each other. So we're going to give the instance of the class instance of variables, and the first one is going to be the index. And we are going to set this to 1 because we're going to start counting from 1. So we're going to set this to 1. And the other thing was, we're not outputting the index, or we're only going to check whether or not it's a multiple of 7 or contains digit 7. So we also want to have a variable that keeps track of what we want to output. So we can call that perhaps cur, short for current. So we're going to do another instance attribute called cur. And we're going to wait and see what this actually should start off as later on. So I'll leave that blank for now. But just so you know, as a summary, so index is the current index we're on. It's always going to increase, so we can keep track of whether or not a number has 7 in it or is a multiple of 7. And current will represent the number that we want to output in our next function. So that might give you a hint as to what we want to implement in the future. But the other thing here was, we want to keep track of the direction, right? Because it could either be going up or going down. We want to be able to keep track of what we want to increment by. So one particular way to implement this would be to use a Boolean value, and it's going to start off as true. We want to add because we want to go in the positive direction when we're starting out, because we're counting up, starting from 1 at the very beginning. So now we want to go over the next method, which is going to take in the instance variable itself and no other parameters. So the first thing we want to check is whether or not we want to increment by 1 or go the opposite direction and subtract one. So in this case, we have the add variable set already to true. So this would tell us that we want to add, right? So that means if self.add is true, we want to add or increment by 1. So we can check that here directly in the if statement. We don't need to say equals equals true because self.add itself is already a Boolean and it'll give us the information we need to proceed. So if self.add is true, then we want to add. So we want to add to the current. So we'll do plus equals 1. And this will increment the current variable by 1. And again, we still don't know what it starts off with because we just want to think about what would make more sense in the future. Because right now, our top candidates would probably be 0 or 1, but we want to see like how our next function works first so we know what to start off with correctly. So the other case would be if self.add is false, which means that we're not adding but subtracting. And that's the way we're going to keep track of our direction. So if self.add is false, we're going to return self.cur, sorry, not return, but increment by -1, or we could just say minus equals 1. So this is what we should have here in the first two conditionals. The next thing we want to check is whether or not we want to flip the direction for the next turn in the sequence, right? So in order to check this, we have to go up here, check our conditions, which are multiple of 7 or contains a digit 7. So conveniently, we have this function made for us, so we can write that first. So here, we should be able to write has 7, and the number we're taking in is the self.index. And the other condition we wanted to check is whether or not it's a multiple of 7, and the way we do that is with our trusty, our good old friend, the modulo. So we can do or. Sorry, I was thinking about Java, so I was going to do the 2 lines, but it's or. Self.index. I am going to go over my colon, but it's okay. Self.index modulo 7 equals 0. It will add that back. So this if statement basically checks whether or not we want to flip the direction for the next turn. And I'm saying next turn because we already know what we wanted to increment or decrement by in this particular turn based off of these if statements. So whatever we're doing down here will only be relevant for the next step, but we're doing it now so that we don't have to worry about it later. So if it is a case that we want to flip our direction, all we need to do is look at what we set to keep track of the direction, which is the add, right, up here. So all we need to do is flip that around. And one way we can do this is by just simply reassigning it to self.add equals the opposite of self.add as it is currently. So the exclamation point or negation will just flip the current value of self.add and assign that to self.add. So it's going to basically just flip-flop whatever we had there previously. The last thing we wanted to do is to increment the index because, again, we are proceeding throughout the sequence, so we want to increment by 1 so we know what number to check next time. So our next step here is to return, or sorry, not return, but change index so that it's 1 higher than it was before. So self.index plus equals 1. And the last thing here we want to remember is that we are returning the value of the current number of the sequence. So in this particular case, it would be self.current. And this is our completed ping pong tracker class. So actually, we're not quite done yet. I forgot to do this part up here. So looking at our next function here, we're going to start off with 1 in our sequence, correct? So we want to be able to return 1 on the first try. But if we set 1 here as the beginning value when you instantiate the ping pong tracker, what's going to happen here when you call next is it's going to check self.add. It's going to say, okay, it's true. We're starting off with adding 1. and it'll take current and add 1 to it, which gives you 2. So by the time you get to the return statement, you'll have 2 if you start off with 1 up here, right? So what we actually want to do is start off with 0. And that might not have been intuitive at the very beginning, which is why I left it for the very end. Oftentimes, you might change whatever you started off with. It's kind of like a title in an essay. Like there's some things that you might change after you've implemented your whole method that makes so that your entire implementation makes more sense. So in this particular case, it makes more sense to start off with 0 for current because you're starting off here by adding 1 or subtracting 1 to it. So it would actually make more sense to start off with 0 up here instead of 1. Some other takeaways from this problem, the main thing is when you keep track of a state of a problem, you want to make sure that you can include all of the variables or information that you need, and you're also concise about it. For instance, in this particular case, the 3 main things we needed were first the index, or basically the nth element of the sequence. So in this particular example, the index would have been like 1, I have my eraser on. 1, 2, 3, 4, 5, 6, 7. That part was pretty obvious. But going on here, index would actually continue on to 8, 9, 10, etc. And the reason why we don't make the index the same thing as current is because there's no particular like relationship we have that's really obvious between the current and index. For instance, 8 and 6, 9 and 5. There's no particular like equation we have to, relate the two. So it makes more sense to just keep them as 2 separate variables, one to keep track of solely the index we're on, and the other one to keep track of the number we want to output. So in this particular case, again, these numbers listed out would be what current represents, or cur in my particular implementation. One more thing to mention is that there are implementations of this particular sequence where instead of using a Boolean here, you're actually just setting it to a value that you want to increment by. So it'd start off with, for instance, I'll write this in red, 1, and then you can just simply increment by self-add instead of having these conditionals here. So I'll just write it on the side. It could end up being something like this, where you just have self.cur plus equals self.add. And there might be other better names for this particular example, but I'm going to keep it as is. And instead of setting self.add to the opposite of what it was before, because the numbers don't really have opposites, we're simply going to set self.add to the negative of whatever it was before. In this particular case, it just flip-flop between 1 and -1, which is the same thing as incrementing and decrementing, or flipping the direction. So this is another possible implementation that you might have already seen, but both of these work in very similar ways. In one instance, you just have a Boolean that keeps track of the action you want to do. The other case, you have the actual number you want to increment by, which is a more direct way of doing it, but both are equally as good. And that's all for my video. I hope this was helpful. If you have any questions, drop them in the ed. And otherwise, have a nice day and enjoy section.